Hello, LFX family. How are you doing? So, if you're new, you are welcome. If you are, if you have subscribed before and you have watched our video, welcome back. So, in today's series, we start our organic chemistry series. So, this is going to be an introduction video to organic chemistry. So, now we are going to start first. Now, first of all, before I will start, I want to talk about a little. Just give a brief introduction to organic chemistry, then we'll now talk about other things that follow. So it's going to make it as easy as I'll break it down so that even if you have issue on organic chemistry, starting from today, you start finding it easy. There's always a fear when we talk about organic chemistry to students, especially the chemistry students, they have this type of fear and nomenclature, all those things. But if you follow the series from the beginning to the end, you are not going to find organic chemistry difficult again. So let's talk about what is even organic chemistry. Organic chemistry is just the chemistry of carbon and its compounds. So carbon and its compound, that is the definition of organic chemistry, with the exception of carbon. And we have the carbonates. With the exceptions of carbon monoxide, carbon dioxide, and carbon what? Triazocarbonates. These are the exceptions. So we don't study this in organic chemistry. We just study the carbons and its compounds. Compounds like when it forms compound like hydrogen, when it forms compound like sulfur, when it forms compound with something like nitrogen, etc. Even the halogens. The halogens which include chlorine, fluorine, bromine, iodine, etc. Now, first of all, why do we even want to even study about carbon? Why do you want to study about carbon first? So why is it that we didn't study about nitrogen as a very big, it's a broad state? Or why do you even want to know, not study about oxygen in a broad state? So why do we just want to study about carbon? The first reason why carbon is unique is that it has the ability to catenate. So when we talk about catenate means that an element or have the ability to link with its own element, as in the same element. Let's assume I have something like, I'm just going to use oxygen first. So if oxygen has the ability to combine with another oxygen, it combines with another oxygen, this is called catenate. But when it comes to something like carbon, carbon has the ability to link between itself. As it's linking between itself, it's forming a big chain. So as it's forming a big chain, it's going to form different, this is called chain. This is called chain. Because it's linking from here to here. So you can bond with each other. And it's forming a big chain. This is called what? Catenate. Once it catenates, it's going to form some type of chain. Like you have something like straight chain. We have something like straight chain. We have something like branched chain. We have something like branched chain. So we have straight chain and also have what? Ring what? Chain. So when this thing catenate, when they join together, they can have the ability to form a straight chain. They have the ability to form a branched chain. And also have the ability to form what? A ring what? Chain. If you're enjoying the video already, you know what to do. So make sure you give us thumbs up as we move on. Now, let's talk about straight chain first. Now, let's have something like carbon, 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 carbon. This is a straight line. This is carbon that's combined in a straight line. You can see this is carbon, 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 carbon. It's combined in a straight line. So this is called what? A straight chain. So you can see something like hydrogen, bonding with hydrogen here, bonding with another hydrogen, and with another hydrogen, 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 hydrogen. Because this is a straight line, the bond is in a straight line. This is called straight chain. And remember I said the catenation can bring about branched chain. So when we talk about branched chain, we now have to do something like this. You now see that this is like a carbon now. The carbon itself will now branch like this. It's not going straight. You now see another one that is going like this. This is called branch chain. You now see another one going like this. You now go like this. So this is branch chain. It joined, but this time the joining now take a U-turn. Do you understand? And the joining now turn to this side. This is called a branched chain. So you also have the ability to form a ring chain. And when it comes to a ring chain, we have this, we have this, we have this, we have this, we have this. This is called a ring chain. Just in a ring format. We have something like this. This is in a ring format. Because it's in a ring format, this is called what? So the catenation can bring about what? A ring chain. Remember, first unique ability of first, while we are studying carbon, the first system is ability to catenate, and I've told you what is catenate. So the second one, while we study carbon, is that let me just use this before we even talk about this. Let me teach you something. Okay, let me even dive in one first. It's the ability of carbon itself to form single bond, carbon to carbon double bond, and carbon to carbon triple bond. What does that mean? Ability of carbon to form single bond. Single bond. This is single bond. This is carbon carrying this particular sign in chemistry show bond. Now, ability of carbon to also form double bond. I'm going to explain this first. Now, ability of carbon to form triple bond. Carbon to carbon triple bond. So what does this mean? Before we explain something like this, let's look at carbon first. Now, the electric configuration of carbon is 1s2, 2s2, 2p2. That's the electric configuration of carbon, which is 2, which is 6. And you know carbon has number 6. So if you look at carbon here, if you look at if it is the hybridization of carbon, we want to talk about the excited state. This is the normal state of carbon. If you have done hybridization, I know most of by now you have done excited state. Before now, if you have not done it, just listen so you just understand. Before an element should be able to combine with another element, especially when it wants to share, it has to be what is called an excited state. Have you ever asked something from an alcoholic before? Someone who just took alcohol now. What do you observe? If the person has 10 naira or 20 naira or even 1,000 naira, he will cheerfully give it to you. Before this carbon will combine, it's going to be in what we call excited state. Now, look at it now. This is a normal state, which is 1s2, 2s2, 2p2. And if we draw the orbitals for this, it's not going to be like this. It's going to be like this. This is S orbital. 1s orbital, 2s, and 2 what? P. You can see, what do you observe here? 2 electrons, which is here, 2 electrons, which is here, and 1 electron. Sorry if you don't understand this particular side. We are going to draw a video about this, but just have it in mind. If you are confused about anything concerning chain configuration or orbitals, drop the comments in this comment section saying that I need video in a chain configuration of orbital or even hybridization. So if you are confused on this, you can drop video, as you can just drop the comments there. I need video on this. We are going to do what? We're going to make sure the LFX team got your back in this coming jam. Just what you are going to do is that make sure you keep following LFX, turn off the notification bell, and make sure you follow us. Once you follow us, we have 100 days running before jam, and we'll make sure we cover you. We got you covered for almost all difficult topics you are going to face. Only what you are going to do is that you have to speak up. Point in the comment section, sir, I need this video, or please, I need this video. I need you to do video on this. Or even drop a question there. We'll make sure we solve it. Okay, back to our video. So have this is 2p2. Now, if we have this, I say that this is a normal state, which we call ground state. Ground states off. carbon. Now, if carbon now want to give out, what is going to be is in excited state. For example, now we have this is excited state. In excited state, it's going to be like this. So excited state is going to be, we have this, we have this, we have this now. This is 1s2. Now, what's happened here is that this particular one, this particular electron will escape from here. Once he escapes from here, it's opening room for another one to come and bond. So what happens? You now see, remember that there was electron here, there was electron here. This one will open room and come here because this is an empty place. So you come here and stay. You get that? Leave opening space for here. Once you open space for here, it's going to now have a mind. Remember that the electron that can stay inside here is in pairs. Do you understand now? So what do you observe now? And the elements can come here and bond. And elements can come here and bond. And elements can come here and bond. And elements can come here and bond. How many do you have? 1, 2, 3, 4. So carbon has the ability to bond with either a 4 different elements, or even just it has the ability to bond with what? 4 elements. It has the ability to bond with it. So remember, that is a unique nature. In our first 20 elements, there is no element that has the ability to bond with 4 what? Elements. So that is this. That's another unique nature of what? Carbon. So now the third one, I remember I told you about this. So before we understand this particular thing, you have to understand this. So carbon is going to be like this. C, having a bond of, having a bond like this, having a bond like this, having a bond like this. How many bonds is it? 1, 2, 3, 4. Which is that 4. So elements can come here and bond. 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 This one carbon itself, only one carbon, can bond with 4 elements. That is why we have millions of organic compounds. Millions. Now, let's talk about this. Let's assume now that this thing wants to bond with something like hydrogen. Hydrogen now. I want to bond. Now this thing, let's assume a bond is how the bonding is going. At the end, you don't see anything to bond with. You don't see something like hydrogen again to bond. What happens to this bond? What happens to this particular bond? This bond will not be like this. This bond will be forced to bond it to what? To move to this side. And once you move to this side, it's going to be C double bond. It will not be what? C double bond. Maybe now this one will now have H. Now have H. This one will be carrying H. This one will carry H. What do you observe? There was no hydrogen here before. Hydrogen here before. And there was no hydrogen before. So this bond will be forced to move here. And we now see something like C double what? Bond. So carbon has that ability to form what we call double what? Bond. Same thing happens in triple bond. Now that's why we now have this. So that is the distance. So what I'm rushing the video a bit is that I don't want it. I know this is just like the introduction. So this is just like an introduction. So we need to round up a bit. I don't want the video to be very, very long. So if you feel that the video is too fast, what I'm going to do is just forward it back, then play it small, bit by bit. You can put earbud or put earpiece, but I know the video will be loud enough for you to hear. So let's now also talk about the last one, the last unique nature of carbon. The last one is that carbon has, as an organic compound, carbon has the ability to form varieties of what? Organic compound. Varieties. Let me give you an example. We have this. This is carbon. Now, this is an organic compound. Remember, I'm putting hydrogen is supposed to be or something like that. Hydrogen here, hydrogen here, hydrogen here, hydrogen here, hydrogen here, Remember that it's carrying 4 bonds. Each carbon must carry 4 bonds. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. So each carbon must carry 4 the same. So this is an organic compound now. So for now, because we have not reached the level, I will not be calling the name for this. So just know this is an organic compound. But this is an arrangement. This is a straight line arrangement. Do you know that if this thing can form like how many carbons you say 1, 2, 3? Then that's that something will can form like this thing has brought out another organic compound that has a different characteristics from this particular one. And that's another one that is like this. Let me just say it like this. This one itself is already having a different characteristic from this. So it's going to have a different characteristic of what? This. So these particular things make what? Carbon unique from other words elements. So now, another thing we are now going to talk about is the characteristic of the what? The organic compound. Characteristic of organic compound. So the first characteristic of organic compound is that they are covalent in nature. They are covalent in what? Nature. What do we mean by covalent in nature? Remember that carbon is a non-metal, and we have basically 2 types of bonds. Basically, the major ones are 2, which is ionic and covalent. Covalent involves sharing of what? Electrons. Sharing. But ionic involves what? Transfer. And that's ionic has to do with a metal and a non-metal. That is 2 elements that have different charge. You already know that a melter have plus charge. A non-melter has what? Minus charge. If there is a transfer between a melter and a non-melter, there will be what? It will form what we call ionic bond. But if in a situation there is what? A bond between non-melter and a non-melter. For example, now carbon and nitrogen. Let's just use this one as an example. What do you observe here? This is a non-melter. What is going to happen here is that they are going to share that electrons. Remember, why they are sharing the electrons, it's either to be in an octet state or duplex state. What is an octet state and duplex state? Duplex state is just like the states that they found that all the elements has a Gauss shell as a last shell. It's going to have 2 electrons maximum in each atom of shell. Not something like 1. That means it is satisfied, it is okay. But an octet state is that as far as it's one more than K shell, you have something like L shell, M shell, N shell, O shell, P shell. You have to have 8 electrons at the outermost shell. So that's the major thing. Now, if you now have this particular situation where you now have the non-melter and the non-melter, what is going to happen here is because they are carrying the same charge. You have minus charge, you have minus charge. This one is carrying a minus charge, this one is carrying a minus charge. This one is carrying a minus charge, this one is carrying a minus charge. This is not going to form what is called an ionic bond. What is going to form here is called what? Covalent bond. So what is going to happen is that they are going to share electrons. Once they share electrons, that type of bond is called covalent bond. Because the chief of organic compound, organic chemistry, is carbon. The whole organic compound are covalent in nature. They are covalent in nature. That's the first characteristic. Then the second characteristic of organic compound is that they have no melting and boiling points. Let's go back to covalent bond. Now, if you have covalent bond now, once you have covalent bond between two elements now, if there's a covalent bond, what you observe is that they have negative. The attraction between these is not strong. Remember, let's go to physics where we say that if you have two different opposite charges that attract, and once they attract, what is going to exist between them is called electrostatic force. So what is going to exist between them is electrostatic force. But this time around, these things are the two negative signs. What is going to exist there is not an electrostatic force. The force that is going to exist between them is going to just a minimal force, which is called something like Van der Waals forces. We have other forces. We're going to discuss about that now. Then let me give you an example of this. Now let me just use have a top cone. I know most of you know what is top cone. Use top cone to something like they gummed the paper on the wall. And you now have all this liquid gum. You know, this gold is 700 naira. So you now use it and gum paper. Which one do you think that will tear out fast? Because it's that the second one, which is the one you use 100 naira gum to hold. Now, what do you observe? That particular distance is very weak. Do you understand that? The particular distance is very weak. So once you just put small heat in any organic compound, it's going to start breaking down. It has a low melting and boiling point. The reason is because they have what? They have weak force that hold them together. So there will be a weak force that holds carbon and nitrogen. The reason is because they don't have what? This is not there's no electrostatic force. If there's electrostatic force, you have to break down that electrostatic force before you now do what? Before you now divide the bond between these two. But because of Van der Waals forces or other forces now, there is just a small heat, or that they see will make it to do what? To break down, making it to have a what? A low melting and boiling point. Another one is that they don't conduct what? Electricity. They don't conduct electricity. For example, your clothes. Your clothes, does it conduct electricity? No. Rubber, does it conduct electricity? No. So those are the things. So another one is that they are highly flammable. For example, now you are playing beside the fire and you're wearing your clothes. It will what will happen? It will just burn immediately. They are highly what? Flammable. So, hope you enjoyed this particular episode. Remember, this is LFX. Make sure you subscribe, turn the notification bell. If you have any question, please leave the question video. So I'll see you in the next video. In the next video we'll talk about the homologous series, the functional group. We'll also talk about the homologous series, majorly functional group. Then I think we'll also talk about archive. So we'll talk about archive group. Then I'll now introduce you to hydrocarbons. So see you in the next video. Stay tuned so I'll keep finding the effects together. See you next video. Thank you very much for watching.